Hi, welcome back. We are continuing in Chapter 9. We are specifically looking at Section 9.4, which is all about counting techniques that we can use in probability. So we are going to cover the fundamental counting principle, permutations of like objects, so things that are the same, combinations and how they differ from permutations, and how we can use counting techniques in probability problems. All right, so if we want to do what's called a permutation on unlike objects, so objects that are distinct from one another, we can first define a permutation to be an arrangement of things in a definite order with no repetitions. So this would be something like how 3 students could stand in line at a Starbucks, right? You could have student A, B, C, B, A, C, C, B, A, and etc. So it's the arrangement where the order matters, and they're not repeating any of the objects. We are going to use the fundamental counting principle to talk about counting the different ways that events could occur. So if an event M can occur in little m ways, after M has occurred, event N can occur in N ways. So then event M followed by event N can occur in M times N ways. All right, so that's a lot of words, but essentially what it's getting down to is, say, if there are 6 different ways we could get a result from a die, a 6-sided die, and 2 different ways to get a result from tossing a coin, then event of rolling a die and flipping a coin has a total of 6 times 2 ways that we can do it. All right, and so one bit of notation and just reminder that you might need a refresher on for this section is called n factorial. So this is when we have an exclamation point next to a number. That means factorial. And so what a factorial does is it multiplies that number with everything else, all the other smaller natural numbers than it. So for example, we could have 5 factorial. That would be 5 times 4 times 3 times 2 times 1, which should give us 120, I believe. So factorial means take that number and multiply it with everything that's smaller than it in the natural numbers. If we want to find the number of ways of choosing 3 initials from the alphabet if none of the letters can be repeated. So the way I like to think about examples like this is to say, okay, I'm going to choose 3 letters from the alphabet, and I'm going to say that the order matters. So if I choose A, then B, then C, that's different than B, then C, then A. The alphabet, the English alphabet, has 26 letters. So there are 26 different ways to choose the first letter. If we're not repeating, then this means that we have 1 fewer letter when we choose our second letter. So since we choose 1 for the first letter, there's only going to be 25 letters left when we go to choose the second letter. So there are 25 ways to choose the second letter. Again, we're not going to repeat it, so we're going to remove the letter that we choose, leaving us with only 24 for the third letter. So there are 26 ways to choose the first letter, 25 ways to choose the second letter, and 24 ways to choose the third letter. And by the fundamental counting principle, we can find the product of those 3 numbers and get our result. So we would do 24 times 25 times 26, which is 25 times 24 times 26. 15,600. different ways to get 3 initials from the alphabet if one of the letters can't be repeated. Okay, so this example is actually following a rule that we have for finding the number of permutations of objects in a set. So the number of permutations of R objects chose from a set of N objects, where R is in between 0 and N, is denoted by N, little n, P, R. So I might read this as N permute R. So I'm starting with N objects, and I'm going to choose and arrange in order R of them. And the way I can get that is by taking N factorial and dividing it by N minus R factorial. So if we think about an example with a baseball team having 9 players, and we want to find the number of ways the manager can arrange the batting order. So if you're unfamiliar with baseball, all this means is that he's going to take his 9 players and put them in order from 1 to 9 to say, you're going to go first, you're going to go second, all the way through 9th. So this would be 9 permute 9. We're going to select 9 of them and put them in order. And so in this case, we would have 9 factorial divided by 9 minus 9 factorial. And you might see a problem here, but we are by convention going to say that 0 factorial is equal to 1. So even though we have a 0 on the denominator, it's not going to cause us any problems. We'll just have 9 factorial over 0 factorial, which is 9 factorial over 1, or 9 factorial, which I believe is 362,800. Using the formula here is actually a little bit more difficult and less intuitive than just following through with thinking through the question, because if you again have 9 places in your batting order, when you go to choose the person who's going to go first, you have 9 options, and then when you choose the person who's going to go second, you only have 8 options. Then when you choose the person who goes third, you're only going to have 7 options, etc. So you're going to have 1 fewer option with every space you go to fill. And 9 times 8 times 7 ... is just 9 factorial, or what we also got using our formula. And in the same way, if we go back to that example where we find the number of ways of choosing 3 initials from the alphabet if none can be repeated, what we did before was just say, all right, 26 times 25 times 24. Or we could use that formula, and we're going to have 26 permute 3. So now we'll have 26 factorial divided by 26 minus 3 factorial, which is 26 factorial over 23 factorial. And when you think about what this actually means, we're going to have 26 times 25 times 24 times 23 times 22 times 21 times ... all the way down to 1, divided by 23 times 22 times 21 ... all the way down to 1. And then all of these factors after 24 are going to pair up and cancel. So that just leaves us with 25 times 24 times 26 times 25 times 24, which is the same as the result we got originally. So there are a couple different ways of thinking about this problem.